Okay, example 5. Use Newton's method to find all the roots of this function. Correct 8 decimal places. When it says all the roots, we need to account for every one possible. And if you recall, with a polynomial function, the highest power of x establishes the maximum number of solutions. I will say that majority of problems, your answers are going to be between negative 10 and 10 for the most part. Some of your word problems, they tend to get some larger answers than that. But just if it's just a general polynomial function, negative 10 to 10 is usually the window that you're looking for. So if you don't see it within negative 10 to 10, it probably doesn't have a root. And I type in the function that we're looking at, 3x to the 5th plus 8x to the 4th plus 21x cubed plus 7x squared minus 4x minus 1. And I can see that it all matches, so we're good there. And then I'm going to just do a zoom 6. Standard zoom window. We only care about where it actually crosses the x-axis. Maybe it does. There it goes. Looks like there's only 3 answers. If you weren't 100% certain at that point, you can change your window, maybe go from negative 100 to 100 or something like that. Again, keeping it negative 10 to 10 because again all we care about is where it crosses the x-axis. See if there's some like hidden roots way off to the negative 100 to 100 range, which I'm guessing there aren't. Yeah, there aren't. So there's only the 3 roots, it looks like. So I'm going to zoom back in. Maybe. There we go. I'm going to go from negative 2 to 2 because all the answers seem to be like right near 0, right? I need to see 3 of them. And I just want to get close enough that I can get a decent first guess for each of these. So there's 1, there's 2, and there's 3. So as far as the first guess is concerned, this one looks like it's maybe about negative 0.6. That one may be negative 0.3. This one may be 0.4. And again, the only thing that can go wrong with these, well, there's 2 things that can go wrong with these. Number 1 thing is division by 0. So if any one of those numbers makes the derivative equal 0, we can't use them. Okay. The other thing that could go wrong is that maybe 2 of them lead to the same answer. We can see obviously there's 3 distinct answers here. So that's the thing that might go wrong beyond that. So if that happens, we just have to guess again until we find some new answer. I do need to enter my derivative as y sub 2. So I know that f prime of x is going to equal 15x to the 4th plus 32x cubed plus 63x squared plus 14x minus 4. Put into that is y sub 2. At this point, I'm going to use the Newton's method program on the calculator. And all we have to do to use that is we have f of x is y1, f prime of x is y2, and then put a guess in. So I'm going to guess negative 0.6. It comes out to negative 0.6. Then we went 8 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. So negative 0.63149275. Now I can hit program Newton again. If I just hit enter, it immediately brings it back up. Negative 0.3 is my next guess, and we end up with, I'll get a different answer. 8 decimal places on that would be negative 0.21715262. And then again, bring up the Newton's method, hit enter one more time. I'm going to guess 0.4. And we get 0.3927951. It's a good guess. 3927951. Make sure you're rounding these to correct number of decimal places. I do account for that when I'm grading. But again, the calculator is doing all the hard work for you. I'd expect to see where you found the derivative on your paper. I want to see what your guesses were, that kind of thing. I'm going to assume that you're doing the right research on the graph to get decent guesses. But just to keep in mind, if you guess anything, guess 96, it'll find you an answer. It just takes a little while longer. And you don't get to pick and choose which answer you're finding. But you see it still found the same answer. But then again, the downfall of that is maybe you don't find the one you're looking for. So if you're guessing near the answers you're looking for, you should find the answer you're looking for.